Hello there. We'll be having a look at the solutions for CET Test 6, especially those questions which are related to the atoms chapter. We'll begin with the 20, question number 21 in your paper. It is to do with the distance of the closest approach. So, distance of closest approach is dependent entirely on kinetic energy. If you look at the formula also. So the R is the minimum distance, the stopping distance that is proportional to the kinetic energy of the alpha particles with which it was fired. Look at this. If momentum is doubled, then definitely kinetic energy has increased. If kinetic energy has increased, since these two quantities are inversely proportional, stopping distance should decrease. With that, I can eliminate D and B because here the stopping distance is shown to increase 4B and 2. Either it is A or it is B. I can further make use of a shortcut, which is kinetic energy is P square by 2M. So if momentum is made 2 times, kinetic energy will be 2 square increased 4 times, right? So since kinetic energy is increased 4 times in the options, there should be a 4 and not a 2. So C is eliminated. I'll go with A for this question. So 21 goes with A. Second one, radius of the first Bohr orbit in hydrogen atom is R. Same first Bohr orbit in singly ionized helium atom. We know that R is proportional to n square by Z. For both atoms, n's value is 1. But Z for hydrogen is 1, whereas for helium it is 2. So the radius of the singly ionized helium atom would be R by 2. Because if Z increases, R decreases for a given value of n. So it should be R by 2. 23rd is tricky, but we shall get around it. What is the concept required over here? For the 23rd one, you need ratio of time. Fir- First, let us write an expression of time. T equal to 2 pi r by v, distance by speed. If only I get to know how speed depends on r, I can calculate the ratios very easily because I have got radius over here. How will I find speed as a function of r? Before that, let's try some elimination. We know that as the electron goes far from the nucleus, its speed decreases. Its speed decreases. You can get this even from a simple application of mv square by r is equal to k q1 q2 by r square as well. As R increases, V decreases. So the ratio of, you know, the speeds should be at orbit R, it should have a higher speed than at orbit 4R. But they are not asking ratio of speed, they're asking ratios of time. Let us see how we can get our way over here. How to express V in terms of R? Well, we know that kinetic energy is the modulus of total energy. This is a result which I am borrowing. Kinetic energy is equal to modulus of total energy. So V square is proportional to 1 by R, or V is proportional to 1 by root of R. So this V over here, I can simply put it to be root of R, or 1 by root of R. This root of R goes to the numerator, and now I get time period proportional to R into root R, or R power 3 by 2. Ha, now my life is easier. Why? T1 by T2 is equal to R1 by R2 whole power 3 by 2. But R1 by R2 is nothing but 1 by 4, because r by 4r is 1 by 4. So this expression is 1 by 4. What is 1 by 4 power 3 by 2? That is 1 is to 8. So the answer should be 1 is to, without using much of n values and stuff like that, we have directly concluded v should be proportional to 1 over root r. Now, question number 24. Uh, the electron jumps from first orbit to higher orbit. Orbital velocity is reduced to one third the initial value. Well, we know that v is proportional to 1 by n. If v became v by 3, n should be 3. V has been reduced to V by 3, one third. So N value should be 3 times its original N value. So I can say that the orbit to which it has jumped should have the value of N equal to 3. And we know that R is proportional to N square. If N is equal to 3, then R has now increased how many times? 9 times, because then it is proportional to n square. So 3 square becomes 9. So the new radius becomes 9r. Just by proportionality relations, we have cracked the problem. V proportional to 1 by n. From there, I got n value as 3. R proportional to n square. If n is 3, it becomes 3 square 9. So the new radius should be 9 times the old one. Now, question number 25. The new energy is minus 1.51 eV. We know that the energy in n state is minus 13.6 by n square. If I put this as minus 1.51, I can find n square to be 9 or n value to be 3. You could divide. 1.51 times 9 will give you nearly 13.6. So to which state did it excite? It got excited to n equal to 3. Now we know velocity is proportional to 1 by n. So if n becomes 3, the new speed should be one third the old speed. So it should be option D. 25 goes with option D. 26th one. 26th one, let us check with the first statement. Acceleration of the electron in n equal to 2 is more than n equal to 1. We know that n equal to 2 has more radius than n equal to 1. What is acceleration? Acceleration is nothing but force by mass. Force is k q1 q2 by r square, electrostatic force divided by mass. So this is acceleration. Well, if radius is less, acceleration is great. If radius is more, acceleration is less. So since radius of n equal to 2 orbit is greater, its acceleration will be actually lesser than n equal to 1. But they have told more than. So option 1 is eliminated. If option 1 is eliminated, definitely I can say A is eliminated. Why? All the statements are not correct. So A is eliminated. Even B is eliminated, D is eliminated. Reason? In B and D, they have given only one is correct and one is not correct. Why? One is not correct. Therefore, A, B, D are eliminated. Only C, hence, becomes the right answer. We didn't even bother to check the second and third statement, just with the help of the first option getting eliminated, which means the acceleration of electron in n equal to 2 is less than n equal to 1. Since we proved this as wrong, we used common sense to eliminate the options between A, B, C, and D. Since 1 is wrong, all statements cannot be correct. 1 is correct, so this is B is wrong. They have told 1 is correct here also, therefore D is wrong. Only remaining option is C. So 26 goes with C. Question number 27. If an electron in a hydrogen atom undergoes transition from n equal to 4 to its lower energy states, there's a formula. Max number of lines is always n into n minus 1 by 2, which is 4 into 3 by 2, which would be around 6. The option is 6. Seedha. If an electron is in excited state and is going to ground state, the maximum number of lines will be n into n minus 1 by 2, which is 6. Now, question number 28. It is asking Rydberg's constant. Now, what is Rydberg's constant proportional to? Rydberg's constant is the formula is given by it is directly proportional to the charge on an electron ka power 4. If you look at the formula for Rydberg's constant, it is proportional to charge on electron ka power 4. Now the charge on electron is there is a new particle. The charge on electron is minus 2e. So E has been increased to twice of its value. So the new Rydberg's constant is 2 power 4, which is 16 times the old Rydberg's constant, which had only E power 4. So 28th one goes with C. Now 29th one. Longest wavelength of Lyman to longest wavelength of Palmer ratio. We know that 1 by lambda is equal to 13.6 times 1 by n1 square minus 1 by n2 square. 1 by lambda equal to 13.6 times 1 by n1 square minus 1 by n2 square. Now, for Lyman and Balmer, longest wavelength will mean very, very small energy. I gave you an analogy in the class to think about as well. If the size of anything is huge, it will move around with less energy. So longest wavelength means smallest energy. Smallest energy for Lyman is from n equal to 2 to n equal to 1. For Balmer, it is from n equal to 3 to n equal to 2. That's all. So when I take the ratios, 1 by lambda of Lyman is equal to, since we are taking ratios, 13.6 I will ignore. 1 by 1 square minus 1 by 2 square. 1 by lambda of Balmer is 1 by 2 square minus 1 by 3 square. What is 1 by 1 square minus 1 by 2 square? 1 minus 1 by 4 is 3 by 4. So 1 by lambda L by 1 by lambda B is equal to 3 by 4 by 1 by 4 minus 1 by 9 is 5 by 36. I take the ratios now, right? So if I take the ratios, I will get lambda B by lambda L is equal to 3 by 4 times 36 by 5, which would give me 27 by 5. But look, it is lambda B by lambda L, but they want lambda L to lambda B. Reciprocal of 27 by 5 is 5 is to 27. So 29 goes with C. The 30th one. 30th one is manipulation of algebra. This I can relate to dipole approximation. Let us see how it is done. We know that h nu energy is proportional to 1 by n1 square minus 1 by n2 square, where n1 is always less than n2. So I can put n1 as n and n2 as n plus 1. When I simplify this using LCMs, n plus 1 the whole square minus n square by n square into n plus 1 the whole square. A square minus b square I can use for the numerator. It is a minus b into a plus b, which is 2n plus 1 by, in the denominator, n square into n plus 1 the whole square. But we know that n is very, very much greater than 1. So I can ignore 1 wherever I see it. So it is 2n by n square into n square is n power 4. N goes with n power 4 as n cubed. So the frequency is proportional to 1 by n cubed. That is frequency proportional to 1 by n cubed is in option C, right? The only thing you need to be aware here is what to put n1 as, what to put n2 as, and which terms to neglect. Whenever an ant is being added to an elephant, we neglect that term. So plus one terms we neglect, we get 1 by n cube. This has been asked in the JEE main exams also. It is a JEE main PYQ. So, but the result is interesting. The if n is very, very much greater than 1, frequency is always proportional to 1 by n cubed. Well, you may notice in the question I have given n minus 1. They are given n minus 1. But you will get the same result even if you put n plus 1. The physics won't change of the situation, right? You'll get the same answer if you get if you even do for n plus 1. If you for this particular case, if you want to do the working, it will be 1 by n minus 1 the whole square minus 1 by n square. Again, you do the mathematical manipulations, use a square minus b square, will end up with the same 1 by n cube dependence. Physics doesn't change just because you change the order in which you are taking the orbits. N to n plus 1 will give you the same answer as n minus 1 to n. So with this, we conclude the solutions for atoms chapter in your CET test 6. Hope you got a quick approach and some logic and perspectives to think about the problems given here. Meet you with the next edition of solutions. Till then, keep learning physics and have fun doing physics.